Okay, so let's get started by giving a quick look to the floor plan of our tower. When I originally saw this one, I thought this project was composed of a set of rotating ellipses, but as we can see here, that is not the case. What we have instead is an oval, and as Grasshopper does not have a native component to create them, we are going to have to go ahead and create our own definition for it. So I went ahead and did a little bit of digging in the Wolfram website, which by the way is an amazing place to find geometry references. So I wanted to see how we could come up with a way of controlling our oval in a parametric way. And I found this mathematical expression where I can have two circles of different radius joined by some tangent arc sections. So this is a one symmetry axis oval, but we could easily mirror the small circle to the left side, so we can have a symmetrical oval in both axes. So our main objective here would be to find our y distance, which would be the center of our joining arcs, as the distance between the centers of the circles and the radiuses can be defined and controlled by us. So before diving into Grasshopper, I would like to talk to you a bit about a concept called operator precedence, which is used in computer programming to clarify which procedure should be performed first in a given mathematical expression. In Grasshopper, we can do this by using parentheses in a hierarchical way. For example, let's take a look to our expression. The order in which we would like to solve it is to start with the operations inside our parentheses. Then we would like to do the operations of the divisor and the dividend separately, and finally perform our division. So this is how we write this expression in Grasshopper. So it will first solve these parts, then go ahead and separately solve these ones, and finally perform our division. So now let's go into Rhino and Grasshopper to check all this information. Okay, so we're going to start our exercise by putting a point in the origin of our viewport. And then I'm going to go ahead to my parameters tab and look for a point parameter, which then of course I'm going to reference to the point that I've just created. So I'm going to right click here, set one point, and I'm going to pick my point. Then the next thing that I'm going to do is to start setting up the variables that I'm going to be using. So I'm going to go ahead and create a slider. And I'm going to set the values of it up to 20, I think would be okay. And I'm going to go ahead and create two copies of it. So the first variable will be the radius of my big circle, and I'm going to set that one I think to 15. And these units would be meters, I guess. So then our second variable would be the radius of my small circle, and I'm going to set that one up to 4.8 or something like that. And the third variable would be the distance between the centers of my two circles, and I would leave that one for now at 16. Okay, so the next important thing we gotta do here is to start setting up our mathematical expression, which we're gonna use to locate the center of our arcs. So I'm gonna go to my math tab, and then here under my script subcategory, I'm gonna select the evaluate component that I have here. And as you can see, this component is only taking two variables right now, so I will have to go ahead and add one more. So to do this, I'm gonna zoom in into my component and then press this plus sign that appears, and as you can see, a new variable input has been created. So I'm gonna go ahead and start connecting my variables into this component. And then we're gonna set up our expression just as I explained you earlier. So I'm gonna right click in my F input, and then I'm gonna select this expression editor option. And as you can see, a new pop-up window appear, and here I can enter my expression. So I'm gonna write it up just as I showed you a couple of minutes ago. Okay, so this is my expression, and then I'm just gonna simply click OK over here. And then as you can see here, we have a new value, which is gonna be really useful later. Okay, so the next thing we're gonna do is to start locating the centers of our circles. And to do this, we're gonna move this point into different positions. So I'm gonna go to my transformation tab and look for some move components. Okay, so I want to move my point, and I want to do it in the x-axis. So I'm gonna go to my vector tab and then look for my x vector component. And I would like to set up this vector with this variable that we have here, which is the distance between the big and the small circle. And then I'm gonna go ahead and place one more point on the opposite direction to mirror my small circle. So I'm gonna create a copy of these two components. So as I want this point to go in the opposite direction, I'm gonna go ahead and add an expression here. So I'm gonna go to my expression tab, and then here I'm gonna type that whatever value goes into f, multiply it by -1. And as you can see, now we have a point in the opposite direction. Okay, so then I would like to locate another couple of points that will define the center of our arcs. And for those I'm gonna need this value. So again, I'm gonna go ahead and call a move component. And this time I want my point to move on the y-axis. So I'm gonna go and call a vector in that direction. And I'm gonna plug it to my expression here. Then I'm gonna plug my move component to my point. And connect this guy over here. Okay, so now I have located this point, and then I'm gonna go ahead and locate another one in the opposite direction. So again, I'm gonna copy these two components. And again, add an expression here, in this case to turn my value into a positive number. Okay, so now we have located these 4 points. So then I'm gonna go ahead and start creating the circles that we're gonna be using to create our oval. So I'm gonna go to my curve tab, and then under my primitive subcategory, I'm gonna go ahead and select my circle component. And I'm gonna place it over here. And I'm gonna start with my small circles first, so this would be the center of the first one. And my radius would be my variable y. Then I'm gonna go ahead and do the same for the other small circles, so I'm gonna go ahead and copy this component. And I'm gonna plug it to this point. So now we have our 2 small circles. Then we're gonna create our big circle, and this one will be just to have a better representation of what we're doing, as we're not really gonna need it in our definition. So again, I'm gonna do a copy of this component. And this time I'll use my origin as my center. And my radius would be my value x, as I mentioned it earlier. So now we have to define the 2 main arcs that will define our oval. So in this case, I could create a couple of circles and simply trim out the parts that I don't need. So I'm gonna call some more circles over here. And to define the radius of this circle, I'm gonna have to add up the distance that I have here, which is the value of my expression, with the radius of my big circle. So I'm gonna go to my math tab and then look for my addition component. And I want to add up my big radius, which is my variable x, plus the value that I have on my expression. But as you can see, this is a negative number and I need it to be positive. So I'm gonna also add a multiplication component here. And I'm gonna multiply this value by -1 so I can turn it into positive. So this would be the radius of my circle, so I'm gonna plug it over here. And then I'm gonna go ahead and create another circle in the other direction using this point that I have here. So I'm gonna copy this component and plug it here. Okay, so now as you have seen, we have created all the curves that we're gonna need to create our oval. The final part of this exercise will be to find the intersections between our circles to trim out the parts that we don't need. To do this, we're gonna go to our intersection tab and then select this curve intersection component. So then we're gonna start finding our intersections, and I'm gonna begin with the intersection between this circle and this one over here. And as you can see, I have located this point over here. So then I'm gonna go ahead and do the same for the rest of my circles. Okay, so that's it. Now we have located all our intersections. And as you can see here, our components return parametric curve values. which we can use to split our curves with. So I'm gonna go to my curve tab, and then in my division subcategory, I'm gonna look up for my shatter component. So now I'm gonna start splitting my circles. So I'm gonna plug this value here. So my TA output will stand for the parametric curve domain of my A input, which would be this one. So I'm gonna be using this output. And also this one over here. So I'm gonna go ahead and press my shift key and drag it into my T input. So I'm gonna go ahead and split the rest of my circles in the same fashion. I'm also gonna do the same for these two circles. Okay, so now that I have splitted all my circles, I just simply need to retrieve only the arcs that we need to create our oval. So to do this, I'm gonna call a series of list item components and select only the items that we need. So I'm gonna call my item component, and I'm gonna plug it to my shader. And as you can see here, the index 0 is the arc section that I want to keep in this case. So I'm gonna be doing the same for the rest, so let's see how it goes. I'm gonna copy my item component, and in this case I'm gonna need to set my item to 1. Okay, so then I'm gonna hide all these circles. And as you can see here, we have created our 2-symmetry oval. So the last thing that we will have to do here is to simply join these segments. So I'm gonna call a join component over here. And I'm gonna start joining all my curves too.